Welcome back to Math 107 College Algebra. In this video, we're going to prove the properties of logarithms that we found in class during the quiz on Thursday. So we're going to do a couple things. First, we're going to let m equal the log base c of a. We're going to let n equal the log base c of b. So, because of that, we know that a equals c to the m, and b equals c to the n. So now, with the product rule, we're going to let log base c of ab equals z. Well, now we know by definition c to the z is equal to ab. But we know what a and b are, so we know that c to the z is equal to c to the m times c to the n. And then properties of exponents tell us that c to the m times c to the n is c to the m plus n. But now, because of the fact the exponential function is 1-to-1, we know that z has to equal m plus n. And now we're going to substitute what z, m, and n are. So we get log base c of ab is equal to log base c of a plus log base c of b. So that's how we derive the product rule. The quotient rule, we're going to start with the same idea, that log base c of a is equal to m, and log base c of b is equal to n. And now we're going to take a look at log base c of a over b, and we're going to let that equal z. So now, same thing, we'll use the definition of the logarithm. So c to the z is equal to a over b. And we have the same thing as last time, that a equals c to the m, and b equals c to the n. So we can put that in here. C to the z equals c to the m over c to the n, which implies c to the z equals c to the m minus n. And again, we have the 1-to-1 property. So z equals m minus n. And then we can substitute everything back in. Log base c of a over b equals log base c of a minus log base c of b. So that's deriving the quotient rule. Then we also have the power rule. So this time, we only need log base c of a is equal to m. So c to the m is equal to a. So now we're going to let log base c of a to the b equal, I don't want to log there, equals z. So same thing as last time, c to the z is equal to a to the b. But now we have the fact that a is equal to c to the m. So c to the z is equal to c to the m to the b. Or c to the z, when you take a power to a power, you multiply the exponents. So that's going to be c to the bm. Well, now we know what m is. Well, first, the one-to-one property tells us that z equals bm. And now we know what m is, and we know what z is, so we have log base c of a to the b is equal to b log base c of a. So that's how we get the power rule. Last rule that we have to derive is the change of base formula. And this one gets a little trickier. So, we're first going to let y equal log base b of a. So now, by the properties of logarithms, we have b to the y is equal to a. Well, now what I'm going to do is I'm going to take the log base c of both sides. So log base c of b to the y is equal to log base c of a. But now we have that power rule that we just looked at. It tells us that y log base c of b is equal to log base c of a. And now I can divide both sides by log base c of b. So I get y equals log base c of a divided by log base c of b. So that's how we derive the 4 rules of logarithms. And in the next video, we're going to take a look at how we can now use exponentials and logarithms in solving equations.